Recording. Good morning, everyone. So, good morning again. Uh, Today, we're going to discuss capacitance and dielectrics. So, what are these terms? Tingnan natin mamaya. Okay? Okay. Pero sige, in connection with the last topic, the last topic was electric potential and potential energy. Okay? So, meron tayong na-calculate na potential energy, no? And that means that we can store energy. Okay? Kasi hindi lang siya puro kinetic, meron din siyang potential which is stored energy. Okay? Parang mga rubber bands, di ba? Yan, no? Yung mga rubber bands natin. Goma, yan. Pansin nyo, they are actually carriers of energy. Pag in-stretch mo, tapos pinitik mo sa kaibigan mo, di ba, masasaktan sila. So, doon, ayun, energy yan, okay? So, when you can store energy, pwede mo siyang gamitin for later use. And same goes with electric potential energy. Okay? So, pwede mo silang in-store and gamitin for later. Okay, so titignan natin ngayon yun. We start with capacitance. So, yung capacitance is a measure of how well a material stores energy. Okay? And yung capacitance, yung formula niya, sorry. Sira na yung mouse ko. Should buy another one. Capacitance, ito siya. Ito yung formula niya. Q is over VAB. While yung potential, yung V is your potential difference from AB. Okay. And then Q is the charge on the conductor. So bakit parang saan ba hinugot yan, sir? Okay, so yung ano dito, yung idea behind it was, pag napansin nila na if you have two conductors, plate with charge Q, and then you have another one of negative Q, pansin mo na there is an electric field between them, then may mga charge sa gilid. Pansin nila na this configuration can store energy. Okay? Okay. So, ayun yung idea behind it. Kaya may Q, may V. So, yung V ay potential between these plates. Okay? May V siya. A, B. Okay. So, ganyan configuration. Napansin nila. It stores energy. Okay. Guys, again, di ko yung ibang equation, di ko na dinederive kasi yung mga biochem majors, ang tinuturo ko na lang ay yung how to use these equations. Kasi hindi naman kayo magde-derive sa exam. Ang papagawa sa inyo is pag-solve. Okay? Yung mga pagde-derive, pang physics major na. So, ang tinuturo ko ay yung paggamit na lang ng mga equation. But, again, you are free to consult if you want a more deeper explanation on things, alternative explanation on some topics. Okay? Okay. Okay. So, continue. The simplest, hindi pa pala ako tapos dito, sorry. Yung capacitance natin, meron siyang units ng farads, named after Michael Faraday. Michael Faraday. Okay. And usually, itong farads, nasa scale siya ng micro, tsaka pico. So, that is times 10 to the negative 6 and times 10 to the negative 12. Okay. Times 10, negative 6, times 10. So, they're very small. So, kung nakakita ka ng 1 farad na capacitor, that would be very, very big. So, 1 farad, katakutan mo siya kasi sobrang laki ng energy na yan. Ang laki ng energy na kayang i-store ng system na yan. Okay? Okay. So, the simplest configuration for a capacitor, yung material na may capacitance. Okay? So, sa mga sci-fi movies, flux capacitor na walang sense. Okay. So, ang simplest example for a capacitor would be the parallel plate capacitor. And by the name suggests, so may parallel may parallel plate, di ba? So may plates ka that is charged up with charges and brought up to a potential difference VAB. Okay? So kaya natin makuha yung mga properties nito, no? Electrical properties at least. Gauss's law, by Gauss's law, gawa ka ng box or cylinder. Cylinder na lang para cute naman this time. That is passing through there. Okay. Ay, sorry. Sira na yung scroll ng mouse ko kaya tumatalon bigla. Okay, so gawa ko ng cylindrical na Gaussian surface there with cross-sectional area na A. Therefore, my electric field or my Gauss's law should be like this. E times 2A. Okay, recall lang naman ginagawa natin last time, no? Yung A ko would be the cross-sectional area of the cylinder. I could write this down as a cylindric circle, but that won't matter kasi magka-cancel lang naman siya in the end. So I just write it down like that. And then, the Q enclosed would be Q. Q over epsilon naught. Tapos, I have my field to be Q over 2A epsilon naught. And we've done this, no? Na yung galing sa Q would be downward and yung galing sa negative Q would also be downward, and in essence, they would add up. So this is just actually times 2. E total would be the double of this, 2A over epsilon naught. Okay, so we have that. And then, the field is pointing downwards. And get the potential difference from that. Okay, so V AB must be equal to integral AB E dotted field DL. Okay, so alam ko naman yung mga dot na product. Yung DL ko, pipili na lang ako ng direction na downward. And they are parallel, so they multiply normally. Q, A, Q. So this DL, A to B. Kasi constant lang yung electric field ko. Okay, and this integral, this gives me a line. And I could call that line D, distance D. Okay, so A minus B to do, or B minus A. Pero I could denote that distance to be D, okay? D, the separation between the plates. So D, VAB. Now we're able to get the capacitance. See? Q over V. So this is just Q QD over A epsilon naught. Yan natin to. Okay. So, Q cancels out and this flips over to the top. I have A epsilon not D. Ay, sorry. D. Okay? Ayan. Tama ba yung nagawa ko? Okay, tama yung nagawa ko. So, the capacitance between parallel plate capacitors is given by epsilon naught A over D. Okay, where D is the distance between the plates, tas yung A would be area of each plate. Okay, so yung cylinder ko kanina dito, in-expand ko na lang siya no, para maging square. Para ma-cover niya yung total, makuha niya yung total area ng plate. Okay, so this is a variable naman yung nilalagay mo na Gaussian surface. Okay, so you can manipulate that to your liking. Okay, what else? So, ayan. Ang ano itsura ng capacitor, no? Yung real life capacitor. Capacitors are like this. Itong nakikita niyo sa screen. Ito yung mga visual capacitors. Ayun, makikita niyo yung mga size niya. 470 microfarads, 1,000 microfarads, 2,200 microfarads. Okay. So, paano sir, ano yan? Parallel plate ba ito? Parallel plate ito, pero nakarolyo siya. Okay. So, meron kang parallel plate. Tapos, i-rolyo mo para maging cylinder. Okay. I-rolyo mo siya para maging cylindrical. So, ayan yung capacitors mo. So, these guys, they store energy. And anong use nila? To send out bursts of energy. Okay? So, lagyan mo muna siya ng energy, then kaya niyang gawin is to send them out in bursts. So, yung mga application nun, no? Para mga flash sa camera, they use capacitors. Kasi normally, if you would try to build a circuit like that, you can't do it without capacitors. Mag-glow lang siya. Okay. Ayun lang yung magagawa. Pero but with the capacitors, you can store energy down to capacitors and then release them to the bulbs so they can produce a flash. So that's one use of your capacitors. Tapos learning lang. Ginagamit din pala ito sa mga microphones. Basically, meron tinatawag na flexible capacitor. Ibig sabihin, yung distance between the plates can change. Okay? The distance between them can change. And nagagamit siya sa microphones by using the vibrations from sound to manipulate the distance of these parallel plate capacitors. Okay? So kapag kumanta ka sa kanila, nagva-vibrate din yung plates. And nagbabago yung distance nila, therefore nagbabago yung capacitance, and so on and so forth. Okay? Okay, so some applications lang para naman ma-appreciate natin itong pinaggagawa natin. Okay. Capacitance depends on the geometry of the system. Okay, so geometry of the system meaning yung distances ng plates, kung gaano kalaki yung area ng plates, what else? So yan, yung shape ng plates, kung circular ba sila or whatever. So doon nakadepende yung capacitance. Okay, usual trick questions sa exam would be asking if ano yung magiging capacitance kapag dinoble mo yung charge, kapag dinoble mo yung potential, pero they won't change the capacitance in essence. Okay, kasi pag dinoble mo yung charge Q, dumodoble din yung potential usually. Okay? So, constant pa rin yung capacitance. Nagbabago lang siya kapag, ayun nga, binago-bago mo yung geometry nung capacitor mo. Okay? So, yan. So, let's try different capacitors. There are a lot of capacitors. So, meron tayong spherical capacitor, which is two concentric spherical conducting shells separated by vacuum. May picture pala, pero sige, wag na. The inner shell meron siyang charge Q, and the outer shell meron siyang negative Q. Tapos, ayan, meron siyang okay. Makakalito yung sinabi niya, no? The inner shell has a total charge of Q and outer radius RA. Parang nakakalito yun. Pero ang gusto niya i-point out ay okay, so meron kang dalawang spherical shell. Wow, nice circle. I love it. Yan, wala na, nabati na. Ayan, kuwari spirito guys, nandito avocado. Okay, ang gusto niya lang i-point out that yung inner shell, meron siyang radius na lalagpas ng onting-onti. So, ayan, nakikita niyo ba lumagpas siya ng onti? And that is called RA. Tapos yung outer shell, meron siyang inner radius, so hindi siya lalagpas. But, mas mauna siya matapos ng onting-onti. RB. Okay? So, ayun lang yung point niya. Nakakalito yun. Pero wala siyang ambag sa discussion. Okay, so how do we do this? Capacitance yung pinapahanap, and what is capacitance? Q over V. Okay? So, hanapin natin yung V. Ayun ang mahalaga, di ba? Hanapin natin yung potential difference from these two. Okay, tatanong ba ako? Hindi ko magtatanong ako. Sige, magtatanong tayo. Sayang naman yung points. Si Marco. Hello, Marco. Are you there? Okay, parang wala si Marco. Si Ray. Hello, Ray. Nandiyan ka ba, Ray? Okay. Ano yung electric field due to the... okay, ano yung electric field na mararamdaman dito sa gitna?
Diba, two conducting shells for like, can I see the problem for it?
Okay.
Two concentric. So, let it be technically at zero. Or, church.
Okay, ito na lang pala yung question. Sino yung may contribution sa electric field between them? Yung nasa inner shell ba or yung outer shell?
Yung inner shell po, yeah.
Okay, very good, very good. May recitation bonus ka rin, syempre. So, tama si Ray na yung inner shell lang yung may contribution. Okay? So, sabi niya, inner shell yung may contribution. And yes, tama yon. Kasi, pag nag-Gaussian law tayo dito sa gitna, so gumawa tayo ng spherical surface dyan. Okay. So, yung ma-enclose mo lang, syempre, nasa loob niya. Hindi yung ma-enclose tong nasa labas. Okay? So, within this two concentric shells, only the inner shell has the contribution. Okay? Okay. So, the field produced by this inner shell. Balik tayo sa pink. Maganda yung pink. Okay. The field produced by the inner shell would be, of course, we have solved it earlier. Sige, gawin natin yung Gauss's law para for everyone. So, kuha ko ng spherical surface, 4 pi r squared, that is in between RA and RB. Variable naman yung R. Okay, I can get close to RA and get close to RB later on. And then the Q enclosed would be Q. Simple Q kasi Q yung nasa yung laman nung shell na nasa loob. Kasi ayun daw, total charge Q. Okay, that simplifies my life. And this is like this. Okay, gawin ko lang siyang vector, no? Q over 4 pi epsilon naught r squared or hat. Okay, radial yung direction as usual. Okay? Okay. Ano napansin nyo dito? Kamukha siya ng, ito ay sa shell. No? Shell. Ano yung sa charge? For a charge, potential niya ay ganito. Ay yung electric field niya ay ganito. Okay? Tignan nyo mabuti, magkamukha sila. So yung mga spherical configuration mo ng charge, they appear na they look like a charge lang din. Di ba? Kaya from these two, hindi mo malalaman, no? From these two to electric fields, hindi mo malalaman dito kung sino yung spherical in configuration niya. Okay? They appear like charges lang. Okay. So in essence, I could say that my shell is actually mukha lang din charge dapat. That is Q over 4 pi epsilon naught r. Okay? But I invite you to solve it from here. So the derivative mo with respect to r ay i-integrate integration pala ito, yung e.dl ito. Okay? So radially yung pag-integrate mo. And you would end up with this. Okay? Okay, now we're done. We're done. So the potential difference from VAB would be the potential in RA minus the potential in RB. Okay, we have that. Therefore, the capacitance is simply Q divided by this potential, Q over 4 pi epsilon naught. Because this is 1 over RA minus 1 RB. Pinactor out ko lang yung Q over 4 pi epsilon naught. Then, Q cancels out. I'm left with, flip over to sa taas, 4 pi epsilon naught. I could simplify this two terms here. Then I'm left with RB minus RA over RA, RB. But ma-flip ulit to sa itaas. So I could simplify further. Buray na lang natin. Now, RB, RA. Okay. Okay. So that's your capacitance. Okay, a nice thing to magandang ina-analyze niyo yung mga sagot niyo para tingnan niyo kung mag-make sense siya. Okay, capacitance is always positive. Capacitance is always positive. Mapapansin niyo sa equation kanina. Sorry. Yan. Epsilon naught is positive. Area is definitely a positive thing. Walang negative na area, no? D is a positive thing also. So therefore, the capacitance is a positive valued constant. Okay, and then tingnan mo yung mga specs nung ano mo, specs nung problem mo. RA is less than RB. Okay, so everything here becomes positive. So yung mga R mo by itself is positive. The only thing you have to worry about is yung denominator. And it turns out, RB is greater than RA. RB is greater than RA. Tama pala sinabi ko. So yung subtraction nila would be positive. Okay. So that's one sanity check to do when solving for things. Okay? Okay. So that's for your spherical capacitor. Now we have another one, the cylindrical capacitor. So meron ka ngayon coaxial cylindrical conductors. May cylinder ka sa loob with radius RA and linear charge density plus lambda. Tapos the outer cylinder or outer tube, kung mas gusto niyo mas ma-imagine, meron naman siyang negative lambda na tawag dito, charge distribution, charge density, sorry. Okay, so drawing lang natin, meron kang tubo na napapalibutan ng another one. Okay, that. Okay, so RA yung nasa loob, RB nasa labas. And then, in a similar way, you have to find the potential in between them. So, to do that, pwede akong dumiretso sa electric field. Diretso na ako dun. By Gauss's law, gawa ako ng Gaussian surface somewhere in between them. Okay. Na cylinder din, kasi cylindrical yung problem ko. So, my field is E, tapos 2 pi r times L, where L is the length of my imaginary surface, my imaginary Gaussian surface. Okay. So L lang muna para I can extend it to my liking. And then closed charge would be lambda L over epsilon naught. I simplify, I have lambda 2 pi epsilon naught r. And if I make it a vector, merong ganyan where r hat distance is distance from axis. Okay? Kailangan ko lang i-define si r hat kasi baka ma-confuse tayo with doon sa spherical na coordinate system na gumagamit ng r. Okay? Okay. And from that, I would get my potential. VAB must be equal to E dotted with DL, but DR na lang siya ngayon. Kasi I would integrate so meron kang, kung imagine mo yung field dito, ano, pag ganun siya. Radially outward. Okay, so I would integrate towards that direction. So DR, yun. And continuing, I have AB 1 over 2 pi lambda over 2 pi epsilon naught 1 over r dr. And this is actually Yung AB ko dito ay RA and RB pala. So, I have to write that down. Okay. Okay, lagyan lang natin ng prime, no? Wala lang, notation lang. Kasi R na rin dito, tapos R pa dito. Wala lang, baka nakakalito siya mamaya. Just to be cautious lang, be careful lang. Okay, so labas ko lang lahat ng constants from the integral dahil wala naman silang effect. And the integral of 1 over r is logarithm. Tama ba? Naalala niyo pa? Natural logarithm prime that is evaluated from RA to RB. And this is lambda over 2 pi epsilon naught. This, tapos ln of RB minus ln of RA. And if we simplify this, yung mga minus ln, nagiging ano lang sila. Pwede mo pagsamahin to become something like this. ln RB over RA. Okay? Nagdi-divide lang yung ano. Okay, now you're almost done. You're almost done. Hindi mo na lang yung capacitance. The capacitance is Q over this guy. Lambda 2 pi epsilon naught. Two pi epsilon ln RB RA. Okay, so that's your capacitance. Simplify it na lang para kayo nang bahala. Okay, so ln is positive again, and everything else is positive. Okay, continuing. So that is your cylindrical capacitor. Ang pinapahanap pala ay find the capacitance per unit length. Okay, tama naman. So this is, simplify ko lang na para ma-assure ako na this is capacitance per unit length. Lambda ln RB over RA. Okay, double check ko lang. Okay. So hindi pa pala ito yung final answer. Nawala yung panulat ko. Oh my God. Wait. Wait lang. I'm back. Okay, hindi pa ito yung final answer kasi yung tanong pala sa atin ay capacitance per unit length. So what we're gonna do is find that. So C divided by L, or curly L if you want that. So this becomes not Q over, so may lambda L, Ln, RB, RA. But this is total charge also, and that cancels out with that. And we're left with 2 pi epsilon naught ln RB RA. Okay, so that's the final answer. Okay, that's the final answer. Okay? And then, sabi ko nga, si capacitor, nag-i-store siya ng energy. So, we need to calculate that energy. And that energy is given by this. Okay? So, the potential energy in a capacitor is U. So, energy pa rin to. So, joules yung units niya. So, it can either be represented by these three expressions. Okay? So, Q squared over 2C. So, depende kung ano meron ka. No? Kung meron kang charge and meron kang capacitance, pwede mo gamitin itong una. Wala ka naman charge, meron ka naman potential instead. You have 1 half CV squared. Or if wala kang capacitance, pero meron ka ring voltage, you have 1 half QV. Ayan. Okay, so that is that. And then meron din tayong tinatawag na electric field energy density. So density is, sabi dito ay energy density, though therefore, this is energy per volume. Okay? Energy, sulat natin. Nakakalito pala. E can be electric field, V can be potential. Okay? So this is like this. Okay? So yung UI, energy per volume. You can have it like this. 1 half epsilon naught E squared. So these are not two different things, okay? Pares lang yan. Kung meron ka naman electric field, you can have this guy instead. Then you just integrate it with the total volume to get the total energy. Okay, so let's try that, no? Let's try that. Ayan. The spherical capacitor kanina, try daw natin yung hanapin yung electric potential energy stored in those in that capacitor by using the capacitance and by integrating the electric field energy density U. Okay, so ano yung nakuha natin ng capacitance kanina? So just buti na lang, sinulat ko na siya dito. The capacitance kanina would be 4 pi epsilon naught. Tapos RA, RB, then RB minus RA. So this is our potential for the spherical capacitor kanina. And I have gagamitin ko na lang to, no? Yung Q squared over 2C. Kasi alam naman natin na yung charge doon is Q. Okay, so U, okay, is Q squared over 2C. Ay, sorry. 2C. Alright. So Q squared as is. Then we have 2. Then we just need to get the reciprocal of C kasi nasa ilalim siya. So this is RB minus RA divided by RA RB times 4 pi epsilon naught. Simplify lang natin para mas mukhang malinis. Q squared over 8 pi epsilon naught. Okay, so 4 pi epsilon naught times 2. Then RB minus RA. RB. Okay, so I have that. So that is my energy for my spherical capacitor. Then we are also asked to find the to find the potential energy by using this electric energy density. So U is 1 half epsilon naught E squared. Sinolve natin agad si E. So alam agad natin siya dapat. Epsilon naught. So E squared is just E dot E. E squared. E vector dotted with E vector, dotted with itself. And this is just 1 over 4 pi epsilon naught squared. Tapos r to the fourth. And sige natin ganito. Q squared. Okay, Q squared. So this is my electric energy density. Okay. Energy density ito. So to get the total energy, you have to integrate mu with the total volume. Okay, so V here is volume. Total volume. And to do that, this is actually okay, so listen closely. Medyo nakakalito to. Okay, dahil yung system natin ay spherical, so we have to integrate over the sphere. Okay, with the mathematical rigor, ang gagawin mo sa kanya would be tatlong integral ito. So with respect to r, with respect to theta, with respect to phi. Okay? So we're gonna show that in a while. Okay. So with that, this is u. Okay? And then this is u una with respect to dr. And then with respect to theta, however, theta is, ano siya? Yung theta ay arc length. So you have to multiply it by the radial vector, the radius. Then this. And then si phi din ay arc length din si phi. So you have to multiply something. And by convention, ang minumultiply dyan is r sine theta. Okay, so sila yung minumultiply. Okay? So gamit dito yung ano, no, gamit natin yung sinabi kong convention doon sa parang last 2 meetings ago about spherical polar coordinates. Okay? Ay, r sine hindi, theta ito. Okay? Theta ito. Kasi ang okay. Si d phi explain natin. X, Y. So, top view ito, no? Top view. Si d phi. Pag ganun siya. Ay, sorry. Pangit. Okay. D phi is this. Okay? So, to get this arc length, you need this length. So, this length here, let's call this capital R. Okay? So, ang kailangan mo talaga is R, D, phi. However, to get R, you have to look back to the yung normal view ng coordinate system mo. So, X, Y, side view na ito, no? So, this is our BV. Okay, so, and what we need is that length, dr. Okay, and to get that dr, let's look at yung r natin. So, kuwari meron tayong r dito. And yung r na to, may angle siya na theta with respect to z. Okay? So, to get the projection, di ba pag kinuha mo yung cosine nito, makukuha mo to. Pag kinuha mo yung sine niya, makukuha mo yung projection niya sa other side. And that is R. Ayun yung kailangan natin, capital R. So, meron tayong R is we find out to R sine theta. So, ito yung sinabi ko last time na theta here is with respect to the Z. Okay? Okay. So, sinabi ko yun sa last meetings. Okay, okay. So, good question. Good question. Yes. So, DR here, from RA to RB. Then, theta would be the total theta, of course. Because we have to integrate the whole sphere. So, that is 0 to pi. And yung phi mo would be 0 to 2 pi. Okay. But, wala tayong theta and phi dito. So, you just have to proceed normally with the integral. So, kapag i-integrate mo si d theta, you have your pi. Sorry. Kapag in-integrate mo pala si phi, so meron ka, tapusin na natin yung integral sa ano, no? Ititira na lang natin yung RA at RB, yung integral with respect to R. So, pag samahin ko si R dito, meron ako extra R, meron ako extra R. So, UR squared ito. dr. Okay? Sa dphi ko, itong dphi, so dphi would run from 0 to 2 pi, the whole circle, the whole equator. Okay, so we have 2 pi. And integral lang sign would be negative cosine. Okay, integral lang sign would be negative cosine, and evaluating that from 0 to pi, makakuha ka ng something na 1 minus 1. So that's 2. And this is all just 4 pi. Okay? U 4 pi r squared. Of course, kung kumpante ka naman sa sarili mo, you can actually proceed from here agad. Kasi alam mo na yung system natin, dependent lang siya sa R. Okay? Sa radius lang siya dependent. Doesn't matter if you're going along the equator, hindi nagbabago yung energy. Diba? And then, di rin naman nagbabago yung energy when you go along the azimuthal angle or the angle that goes from North Pole to South Pole. So, you can actually integrate by shells. So, this is a shell. Diba? So, to build the sphere, you can actually combine shells, diba? So, you just have to integrate the shells along the radius. Okay? So, that's a faster way of doing things. Okay? Sabi ko nga sa inyo, yung mga surface area natin, kapag in-integrate mo sila, nagiging volume. So, ito. At yung surface area ng sphere, kapag in-integrate mo with respect to dr, nagiging volume yan. Okay, now we just plug in things. So, haba. Labas na natin si q squared epsilon. Q squared epsilon naught. Oops, numerator pala si epsilon naught. And then 2 times 4 pi epsilon naught squared. Have that. And then inside, you have 1 over r to the fourth. Lalabas ko na rin si 4 pi. So, my integral is RA, RB, then r squared over r to the fourth dr. And this is just so 1 over r squared lang ito. Ayaw gumana ng pen. Okay. Yan na. Ano pa ba? Pwede pa ba tayo i-simplify dito? Dito ko na lang muna isulat yung sagot. Okay, so q squared is as is. And then this is 2 pi, and this is 16 pi squared epsilon naught squared. Tapos may epsilon ako dito, not epsilon naught. And this is that. Okay, dinat-dot-dot ko lang muna yung integral na. Tamad ako magsulat eh. So, squared 8 pi epsilon naught. Tama? And then, the integral of 1 over r squared is 1 over r negative. So 1 over r negative evaluated from RA to RB. Okay, and then if you write this down, we have 1 over RA minus 1 over RB, that if you would simplify this, combine them, you're left with RA, RB, RB minus RA. Is that what we got? RB minus RA over RA over RB. Okay, same naman nakuha natin. Nice. Okay, so same lang sila. Same lang sila. Okay. So that's okay. So that's it for the electric field energy density. Okay. So tapos tayo sa capacitance. So that's it for the capacitance. So it stores energy. Now we're here to, actually tapos na yung parang in general idea ng electric fields and such. Okay. We now go on to, kasi parang lahat ng dinidiscuss natin, di ba, vacuum yung. So what if we put materials there? What happens? So we now go to the topic of dielectrics and polarization. So dielectrics is a fancy term for insulators. Bakit natin sila tinatawag na dielectrics instead of insulators? Kasi insulators, it gives you a notion na electricity is not flowing through into materials. Okay? So, that's a naive interpretation of things. Yung mga tinuturo sa atin ng bata, no? Pag insulator, hindi na dumadali electricity. But that is wrong. Okay? So, everything, lahat ng bagay na daluyan ng kuryente, ng electricity. It's just that sa insulators, mahina yung current doon sa material, you don't feel it very much. Okay? So, from now on, tawagin na natin silang dielectrics para fancy-schmancy tayo. Okay? And then, kapag may material ka, syempre yung material mo, may molecules, may mga protons, may electrons, ganyan. So kapag binombard mo siya ng electric field, what happens is that yung mga materials and the molecules inside of them, they would align accordingly. Okay? So syempre, kapag ganito yung tingnan niyo dito sa screen, kapag ganyan yung electric field, susundan yan lahat ng positive mo. So everything that is positive goes to the right. And then the negative charges goes to the left, opposing the direction of the electric field. Okay? So yung mga valence electrons, they usually do the moving. Okay? So yung mga outer shell electrons, they do the moving. They oppose the electric field. They go to the other side. Okay, so ayun yung nangyayari. May tinatawag tayong polarization ng material. And you can see that, mapansin nyo dito sa inside ng mga charges, these guys cancels out. Yung mga na-charge na ganyan, they cancel out. And you're left with the positively charged surface here and a negatively charged surface here. So the material is now polarized and meron siyang sarili niyang mga charges. Tinatawag natin siyang bound charges. Okay? So yung mga bound charges, these are just the charges that are that emanate quote unquote when being affected by electric fields. Okay? So syempre meron kang surface charge, meron kang surface charge. They produce electric fields also. And kung titingnan nyo maigi, yung pinaproduce niya electric field will be opposite. Okay? So meron siyang ang pangit ng color na ginagamit ko. Ano ba ito? So green na yan. They make a field that is opposite. And what happens in the net electric field inside of this material? Okay? So it gets less than E na electric field. Kasi tinotone down ng mga bound charges yung electric field mo. Okay? Okay. So we have that. And amazingly, if you strengthen the electric field, so kung kunwari sobrang lakas ng electric field, what happens, di ba? So yung mga charges dito, they would eject. Ay actually yung mga negative charge yung kumakawala. Sige, baka pulisin nyo ako, sorry, hindi ako chem major. Okay, so yung mga negative charges yung kumakawala. So kapag kumawala, ano ibig sabihin? They would be ionized. Ionization. Okay, so to ionize something, you just put it in a strong electric field. Okay. And then the electrons would get ejected from the molecules. Amazing, di ba? Okay. What else? Okay, meron pa ako isang note dito. So yun sa notation ng dielectrics and insulators. Meron kasi tayong tinatawag na dielectric breakdown. Nasa libro nyo yun. You can read about that. Dielectric breakdown. So, nagbe-breakdown yung dielectric so that the electric field could flow freely. Okay. So, may mga properties yung ganun yung. Kuwari, mga plastic, no? If you bombard them with a strong enough electric field, they would undergo breakdown. And yung insulating properties nila, they would vanish. They would, the electricity is now freely flowing into the material. Okay. Kaya ina-avoid natin yung paggamit ng word na insulator. Okay? So now, ang pagbabago mo is meron kang dielectric constant. So the dielectric constant is this guy, K. Okay. Or in some other books, epsilon R. Hindi ko rin alam bakit, pero ayan, epsilon R. Notation lang naman. But it points out to the same constant. So yung mga constant, wala silang units. They're just constant. Okay. Ito si permittivity. Permittivity. And this is also permittivity. Permittivity of free space nga lang. Okay? So this is yung epsilon naught na ginagamit natin, permittivity of free space. So dielectric constant is a dependent on the material, on the chemical properties of the material. Okay? Ayan. And if you have a K of 1, so that is your for vacuum. No? Kasi di ba pag pinlog in mo siya sa equation mo, lalabas ganito. 1 epsilon naught. So that is epsilon naught. Okay. So 1 is for vacuum. Tapos if for k approaches infinity, this is for an ideal conductor. Well, actually conductor in a sense. Conductors in a sense. Okay, so ayan. Kasi napansin nga natin dito, if you have a dielectric in your material, or if you have a material, okay, tinotone down niya yung electric field. And napansin natin sa conductors, totally toned down yung toned down yung electric field. Kasi electric field is zero inside the conductor. Okay, anong sense nun? So yung K niya infinity. Mag-zero out yung electric field mo inside the conductor. Okay? Okay. Okay. So, capacitors, pag nilagyan mo siya ng dielectric, which is a usual practice, kasi, di ba, yung parallel plate capacitor natin, ang effort niyan kung gagawin mo vacuum do sa loob. Kung vacuum sa loob, mahirap, di ba? So, ginagawa sa kanya, sinasandwich siya sa dielectric. Okay. And it turns out, as you can see here, pinapalakas niya yung capacitance. Okay? So, C is equal to K, C naught. So, C naught is the capacitance without the dielectric. And you can see here from this equation alone that dielectrics make the capacitor stronger. By stronger, meaning mas malaki yung nag-store niya energy. Okay? Okay, so yung sa C naught natin, di ba epsilon naught A over D siya kanina? So nilagay lang yun doon, nilagay lang yan dyan. Tapos mapapansin nyo, meron siyang K epsilon naught. And that K epsilon naught is just your permittivity. You have that. Okay, so now let's try things. Let's try an example, a very long example. So hanggang H yung tanong niya. Ang daming tanong, di ba? Meron kang parallel plate capacitor daw. Meron siyang area ng 2,000 cubic centimeters, square centimeters. So, pinonvert niya na lang buti naman. And then, yung distance niya, distance between the plates would be a centimeter. Converted na din naman. Then, you connect it up to a power supply. I-charge mo siya sa potential na 3,000 volts or 3 kilovolts. Then, you disconnect it after ma-charge mo siya. Ang mangyayari daw is then we then insert a sheet of insulating plastic material between the plates. Okay. And completely filling the space between them. Napansin mo daw na yung potential difference bumaba to 1 kilovolt. Pero yung charge on each capacitor plate remains. Okay. Find the original capacitance, C naught. Okay, madali lang yung C naught, di ba? So, A. Let's pangit. Okay, ayaw na lumipat. C naught is just epsilon naught A over D. And A is given and D is given. E naught is a constant. Epsilon naught is a constant. So, A must be 2 times 10 to the negative 1. And this is 1 times 10 to the negative 2. epsilon naught times 2 times 10. Okay. So you plug this into your calculator. Kasi ito ay 8.85 times 10 to the negative 12. Hassle, di ba? Lit na number. And this gives me 177 times 10 to the negative 9. Negative 12 farads. Kasi ito ay capacitance. And this is just 177 picofarad. Okay? Nothing new, nothing new. Plug in lang tayo ng value sa capacitance. Okay, and then we proceed with letter B, the magnitude of the charge on each plate. Okay, gamitin lang natin yung formula for your charge. So that is Q times CV. Okay, so C naught would be this guy, the initial na capacitance. V naught would also be the initial charge potential difference. So this is 177 times 10 to the negative 12. Then I have my voltage to be 3 times 10 to the 3 volts, kilovolts kasi di ba? 3 kilovolts. Let's check that. 3 kilovolts nga, 3 kilovolts. Okay, so this is actually 531 times 10 to the negative 9. And this is just 531 nano coulomb. Okay, incorporating the units. Next would be letter C. So the capacitance after the dielectric is inserted. Sabi kasi kanina, charge remains constant. So Q is still this letter B. Ang tinatanong na lang would be the new capacitance. So that will be C. C na lang siya. Q over V. Yung V mo dito, gagamitin mo would be the given that yung bagong potential difference. So we plug things in. Q has to be 531 times 10 to the negative 9. And then V would be 1 times 10 to the third power. Okay, 1 kilovolt kasi. And this is 531 easily times 10 to the negative 12. So this is 531 picofarad. And then letter D, dielectric constant K of the dielectric. Dali lang itong D, no? Kasi C must be equal to K times C naught. Okay, pwede mo siya mentally actually. So C naught natin, balik lang muna natin. So this is actually 531 must be equal to K. Tinanggal ko na yung mga times 10 to the 12 kasi picofarad dun yung una natin nakuha. 177. 177 picofarads. And napunta yung 177 to 531 by a factor of 3. Okay. So, ayun sinasabi kong pwedeng mentalin. So, K is just times 3. Okay, so divide nyo na lang kung ano. Kung hindi kayo komportable din sa sinasabi ko. Okay, so the dielectric constant must be K and the permittivity E is K epsilon naught. So that's 3 times 8.3 85 times 10 to the negative 12. And this is, pangit naman ito, 2.66 times 10 to the negative 11. The usual units would be Coulomb squared, Newton meter squared. Okay, so yung units nito, kinopya ko lang sa epsilon naught. Okay, kasi unitless naman yung constant K. So, yan. Coulomb squared per Newton meter squared ang permittivity. Next would be F. Okay, ito parang bago to. The magnitude of the induced charge Qi on each face of the dielectric. Okay. So, that is, ano letter yan? G? I, F pala. Sorry. F, so number F, letter F would be asking Qi. Okay, so let's take a slow approach here kasi saan manggagaling ito. Okay, so drawing natin yung problem. We have a parallel plate, di ba? Okay, and then another one. And then the top plate is charged with that. So the electric field is going down. Okay? So kuwari ito yung parallel plate ng system. So charged yung taas with positive, then baba negative. So therefore the field is going down. Okay, nagda-download yung Steam. Wait lang. Okay, yan, post. Going back. Baka ma-disconnect ako dito sa Zoom pag natapos yung pag nagtuloy-tuloy yung download sa Steam. Okay, so ito yung natin, ito yung initial setup natin. May parallel plates ka, which is held up to a potential difference. So may field yan. Okay, so yung E natin would be something like this. Okay, kinalculate na natin to. Alam na natin na ito siya. Okay? Now we have inserted a dielectric inside this material. So yung pink yung dielectric, yung plastic na nilagay mo. Okay? So you have that. And nakita nga natin yung effect ng polarization doon sa material, di ba? So the positive charges inside that material will follow, and then the negative will oppose the direction of the electric field. So therefore, meron kang positive charges build up here, build up there, build up there. And then meron ka dito, minus. Okay? So meron kang another field na pataas. We're simply just opposing the original electric field. Okay? So I'll call that EI, which is sigma I over epsilon naught. Okay? So the total field would be E. Let's write down as E. And this is negative no kasi pataas siya. So the total field would be epsilon naught. Or pwede mo balik rin kung sanay ka na pababa yung negative tas positive upward. But in the essence remains the same. Remains the same. Pag inad mo sila, they are opposing. Therefore, they should subtract each other. So I have something like this. Okay. So this is the total field that I'm experiencing in this region. Okay. And then, amazingly, this is a new thing. Okay, guys. Hindi ko pa nasulat sa slides ito. But E is actually epsilon naught over K. Okay, ibig sabihin lang na yung yung electric field mong original, matutone down siya by amount of K kapag nasa dielectric na. Okay, so the new field is toned down by an amount of 1 over K. So I just plug in it there. Okay, plug in ko siya doon. So I have something like this. Sigma minus epsilon naught. Yung E naught ko, yung electric field ko without anything would be sigma over epsilon naught. So this is sigma over K epsilon naught. And epsilon naught cancels out. So this actually becomes sigma minus sigma I, sigma over K. Okay, then I isolate sigma I because that would be the amount of charges that is induced. So I have sigma 1 minus 1 over K. Okay, let me grab my notes. Okay. Okay, so we have this surface charge density sigma I. So this sigma I would be the ones that tell me that those are the induced charges. Okay. And yung tinatanong sa atin ay magnitude of the induced charge QI. Induced charge yung tinatanong sa atin. Total charge QI. So therefore, I just multiply this with the area. So sigma times area would be the total charge QI. Must be equal to Q times 1 minus 1 over K. And 1 over K is just 1/3. So is just 2/3 ng total charge ko, which is 531 times 10 to the negative, nawala. Times 10 to the negative 9. Okay? And this is, if you calculate this has to be 354 times 10 to the negative 9 coulombs or nanocoulombs. 354 nanocoulombs. Okay? Okay. So this is for F. Okay? So bago to. Hindi ko lang kasi nalagay dun sa ano. Importante ito. Dinerive lang natin siya in this section. So nakalimutan ko siya ilagay dun sa slides mismo. Bago yan. So you have to jot down these guys on your notes. Okay, proceeding. Ang next na tanong would be G. So the original electric field between the plates. Okay, there is a lot of ways to solve this. Okay, so E daw, no, initial field daw. So pwede akong gumamit nito, sigma over epsilon naught. And this is just Q over A epsilon naught. I have my Q, I have my A given yan. Epsilon naught, alam ko din. Also, I could use the potential difference between the, I could use V over D. I can also use this. Since given yung potential, given din yung distance. Okay? This is actually safer kasi this is all given. Yung Q mo dito, sinolve mo to. Kung nagkamali ka kanina sa Q, so kung ginamit mo tong equation na to, you would be wrong. Okay? Okay, so dahil kampante tayo, gamitin natin to. So Q is 531 nanocoulombs. That's times 10 to the negative 9. Yung A natin is 2 times 10 to the negative 1. And we have epsilon naught to be 8.85 times 10 to the negative 12. So 13 minus 9. So we have times 10 to the 4th power. Then you multiply these 3, divide and multiply these 3 guys. So 531 divided by around 17. And you're left with a nice round number, which is 30. Okay, and I can write this down as 300 times 10 to the 3rd power. Wala lang, nice lang. Okay, so kung gusto nyo gawin din to, yung ginagawa ko, you could go to your calculator. Actually, ang bibigay sa'yo dito ay 3 times 10 to the 5th power. Okay? And then, you go to your calculator, you press the eng. Okay? So, yung purpose niya, ililipat niya sa engineering notation yung scientific notation mo. Okay. So, I think this would go up. So, magiging 0.3 times 10 to the 6th ata siya. Ay, hindi, pakanan pala siya. So, pag pinindot mo yung dito, ang mangyayari ay magiging ganito siya. 300 times 10 to the 3rd power. If you press shift plus eng, pabaliktad naman gagawin niya. Pupunta siya to the 6th. Okay, basically multiple of 3s. You try to explore it. Okay, so you do that. You try to do that on your own time. So, ayun yung purpose niya. Weird, hindi pa dinagdagan ng isang letter. Para hindi siya mukhang English. Kala mo kasi mukha siyang language button. Pero hindi. Ano siya? Engineering notation yan. Okay, so units would be volt per meter or Newton per coulomb. Okay, so we have that. And then, lastly, H. So the electric field after the dielectric is inserted. So this is easy. So you have this equation. So you divide the original electric field by the dielectric constant, which is 3. So we just divide this by 3. So yung H natin, yung dulong tanong would be dividing things by 3. Okay, so 300 times 10 to the 3rd. So this is just 100 times 10 to the 3. Newton per coulomb. Or again, volt per meter. Okay, so haba nun. Dami natin sinagutan. Amazing. Okay. So that is your capacitor with the dielectric. So the dielectric the dielectric strengthens your capacitor, strengthen its ability to store more energy. Okay. Ang galing, no? It aligned with life na mas madali gawin tong may dielectric kaysa yung may mga yung vacuum lang. And it turns out, mas malakas pa siya in that way. Okay, energy density. Ano mangyayari sa energy density mo kapag meron kang dielectric? Ang mangyayari lang is basically papalitan mo epsilon naught ng epsilon na lang. Okay? Or mumultiply mo siya ng dielectric constant. So you have that. Okay, so find the energy stored in the electric field of the capacitor in the previous example and the energy density both before and after the dielectric sheet is inserted. So yung previous ano lang natin, previous example lang natin. We're just gonna grab the results that we have answered. Okay. So U not the initial energy initial energy is 1/2 C V squared. C naught V naught squared. Okay? So you plug in things. So 1/2 ng 177 picofarads. So ito yung mga previous na sagot lang natin. We're just gonna collect them. 3 kilovolts squared. So this is 7.797 times 10 to the negative 6 joules or microjoules. Then, kapag nilagyan mo na siya ng dielectric, ang mangyayari ay magiging 1/2 C V squared so dito 531 picofarads yung kanina, then 1 kilovolt yung potential, 266 times 10 to the negative 6 joules. Okay, so that is your new energy. And then the energy density is small u. So 1/2 epsilon naught E naught squared. So this is 1/2 epsilon naught. Kukopihin mo lang yung sagot natin sa E, which is 300 times 10 to the E. Squared. And this is 0.398 joules per meter cube. Okay? Kasi yung energy density natin, energy density nga, so that is energy per volume. Okay? Joules per cubic meter. So energy over volume. Then the energy density after would be 1/2 epsilon E naught, E squared. So this is actually 1/2 times 3 epsilon naught E squared. So 3/2 epsilon naught times yung 10. Ay, 30 lang pala ito, no? Ay, 100 times 10 to the third power squared, and this gives me 0.132 joules per meter cube. Okay, so that's it for that example. You can try din. Nasa libro yan, nasa libro. I'm just laying down the steps on how to do it. Okay. Sabi natin, or just an evaluation of the things that we're doing. Sabi natin, kapag nilagyan mo ng dielectric, tumataas yung energy na makakaya niya ma-store. Okay? Pero napansin nyo na bumaba yung energy. Energy stored. Bakit ganon? Kasi hindi na charge yung ano. Okay? Pansinin nyo dito sa sinabi sa tanong. Dinisconnect na siya sa power supply. But if you continue connecting it to a power supply, you can charge it up to a much more higher energy. Okay? Kaya lang siya bumaba kasi kinuha na nung material, yung dielectric, yung other energy. Okay. So, baka may nag-wonder rin, saan naka-store yung charge? Ay, saan naka-store yung energy? Hindi namin din alam. Hindi namin alam kung nasa electric field ba siya, nasa charge ba siya. It can be both. Okay. Pero ayun ang ginamit niya. Energy stored in the electric field. Kasi pwede mo naman isipin na nandun nga siya. Pero pwede mo rin naman isipin na nasa charge. Ayan. Okay, and lastly, for dielectrics, you also have your Gauss's law. You can there's a special Gauss's law for dielectrics. Okay, kung wala spherical yung dielectric mo, cylindrical, or planar. Okay, again, for those three lang yung pwede, no? Pero pwede naman na superposition of those shapes. Okay, kasi yung electric fields nga natin, they are guided by superposition. So you just add those individual contribution. Okay, don't forget that. Okay. Okay, so yung dielectric constant, lalabas lang to. So the inscription remains the same. Description. Ang bago lang is you have this Q enclosed free. Ang pangit naman. Ang usual notation namin ay QF enclosed. Okay? So free charge that is enclosed. And then I divided by K epsilon naught. But this is just epsilon. Okay? Okay. So ano tong free charge? Okay. So free charge enclosed by the surface. So nothing new. So everything that is not bound is free. Everything not bound is free. Okay? So ano yung mga bound? Yung katulad kanina, meron tayong bound charge na sinolve. Ito yung mga induced charges. Okay? Sa dielectric mo. So nagkakaroon kasi ng excess charge yung dielectric mo dahil nagre-rearrange nga yung molecules sa loob. So yung iba doon, yung positive mo, yung negative mo, they reside on the surface and those charges are bound. Okay? We don't add them to your calculation. Okay? So kapag puro dielectric lang tapos walang charge na naka-sprinkle somewhere, then there is no free charge. Okay, so try natin para naman. Okay, so gamitin daw natin yung Gauss's law for the spherical capacitor, yung kanina. Ngayon naman, however, yung volume between the shells is filled with an insulating oil with dielectric constant K. Okay, so kanina, we have meron kang Q on this surface, Q plus Q. And then the other one, you have negative Q on that. Okay, and the new thing about this example would be filling it up with some oil. with the dielectric constant. Okay. Okay. Okay? So wala tayong gagawin sa dielectric, hindi natin siya papansinin. Ang papansinin lang natin would be the charge on the conductor. Dahil sila yung mga free charges, they can move. Okay? So whatever charges na ma-induce ko dyan sa oil, I don't care about it. So using the same thing, E times 4 pi r squared, ganun pa rin. Must be equal to Q, yung nandito sa conductor ko, yung naka-sprinkle dun sa conductor ko. Then I would just have epsilon. My field is now Q over 4 pi epsilon r squared. Kung mapapansin nyo, everything almost remains the same. Nagbabago lang yung epsilon naught, nare-replace siya with epsilon. Okay. Siyempre, for more complicated things, hindi ganun yung nangyayari. Pero in the simple things like this, napapalitan lang yung ano niya, yung epsilon naught by epsilon. Okay? Okay. However, kung wari, bigyan kayo ng problem na wari, planar yung slab. Meron kang conductor. Conductor ka. Planar conductor. Tapos sa ilalim niya may slab ng dielectric. Okay. So may slab ng dielectric. And now you're getting the electric field for this. Para infinite slab ito. And you're just getting the electric field at some place this. So gagawa ka ng kuwari Gaussian surface in this region. Okay? Dalawa yung gagamitin mong kinds ng Gauss's law. Kasi iba dito, iba dito. So nasa vacuum itong taas, nasa vacuum yung kabilang area. So yung E, i-split siya into 2. Okay? Okay. So ganun. So isa epsilon lang, isa epsilon naught. Magbibigay ako ng prob set syempre para matry nyo on yourself. With yourself. Okay? So ayun, that is for your capacitance and dielectrics. Tapos na tayo. Next week would be interesting kasi ito yung useful sa buong buhay nyo. No? Sa mga board exams nyo. So next week would be circuits. So useful yun pag mag-ano na kayo. Strong and independent person na gagawa ng sarili mong wiring sa loob ng bahay, etc. etc. Okay, so any questions? Bigay ko na lang sa yung prob set will be weekend or Monday. I mean, bibigay ka ng weekend or Monday. Tapos deadline ay Thursday. Okay, any questions? Yan. Kung wala naman, dismiss na. Thank you, class.